There's a new kind of perception that's emerging on our planet. It isn't human, it doesn't need to sleep, it never gets tired, and it can see things that are fundamentally invisible to you and me. Really think about that for a second. An area that covers hundreds of square miles, filled with millions of trees and shadows and all sorts of look-alike shapes. Could you, personally, find one specific hidden object in all that? The answer, of course, is no way.
But here's the thing. A new form of intelligence can. It can sift through that entire forest in just moments and pinpoint exactly what it's looking for. Now, this isn't science fiction anymore. This is the new reality of AI and intelligence, and we're going to break down exactly how it all works.
Okay, so let's dive right into this. To really understand this incredible new capability, we first have to get our heads around the massive scale of the problem it's trying to solve. And that problem is all about data.
If you look at the history of intelligence, it's really just a story of getting more and more and more information. It started with actual physical aerial photos back in World War II. Then, during the Cold War, we added things like signals and more advanced imagery intelligence. But today, our satellites, our drones, all of our sensors, they're generating petabytes of data every single day. It's an unimaginable flood of information.
And that brings us to the core issue. A human analyst, no matter how skilled they are, simply can't keep up. We all have cognitive biases, we get tired, we suffer from information overload. Let's be honest, humans were never built to process data on this kind of planetary scale. So there's this huge gap between the information we're collecting and the knowledge we can actually use.
So, how do you solve an impossible problem? Well, you invent a completely new kind of perception. And this is where AI steps in, not just as another tool, but with this powerful set of capabilities that are kind of like super senses.
First up, you've got computer vision. This is basically like giving a machine superhuman eyesight. It's the AI's ability to look at an image or a video, and instead of just seeing a bunch of pixels, it actually understands what it's looking at. It can identify objects, recognize activities, and spot even the most subtle changes.
And the process itself, when you break it down, is deceptively simple. The AI takes in a massive satellite image, scans it for any objects it's been trained to recognize, and then it just flags any anomalies for a human analyst to look at. It's really the perfect partnership. The machine does the impossible work of finding that needle in the haystack, and then the human provides the final judgment.
Next up, we have natural language processing, or NLP, and this is the AI's ability to listen and read at a scale that is just staggering. It can devour millions of reports, communications, open-source articles, understanding the context, the sentiment, the key pieces of info, basically doing in minutes what would take a whole team of humans years to get through.
So what's the engine that powers all of this? Well, that's machine learning. You can think of it as the brain that actually trains these super senses. By feeding it just enormous amounts of data, the AI learns to identify patterns all on its own, like what a tank looks like from space, or the specific linguistic patterns that might signal an upcoming threat, all without a human having to sit there and code every single rule.
Okay, so we've got the tools: computer vision, NLP, and machine learning. And when you start combining them, you get capabilities that honestly feel like something close to magic. This is where AI starts to perceive things that are truly beyond our own human senses.
This chart really puts it all into perspective. On one hand, you have a human analyst scanning for known targets who can be fooled by camouflage or just plain old fatigue. On the other, the AI is scanning petabytes of data and can spot a target from a faint heat signature that's totally invisible to the naked eye. A human predicts based on experience. The AI predicts by detecting microscopic shifts in language and logistics across thousands of different sources.
And it gets even more detailed. AI can see the heat from a vehicle's engine even when the vehicle itself is completely hidden from view. It can trace the almost ghost-like digital footprints of a really sophisticated cyber attack. Or it can identify thousands of fake social media accounts all working together in some big disinformation campaign. These are patterns that are, for us, simply imperceptible.
Now, obviously, this level of power is a total game changer. But it doesn't come for free. Every major technological leap forces us to ask some really difficult questions. And believe me, AI is no different.
This technology really presents a stark contrast. On one side, you have all this promise, unbelievable speed, enhanced safety, deeper insights. But on the other side, you've got the peril. Things like algorithmic bias, the potential for pervasive surveillance, and the very real risk of an uncontrolled arms race.
Which leads to one of the most difficult questions of our time.
If an AI makes a mistake, let's say a misidentification that has critical life-or-death consequences, who's ultimately responsible? Is it the programmer, the person who used it, the machine itself? The lines of accountability are getting dangerously blurry.
And a huge challenge here is that an AI is only as good as the data it learns from. It isn't biased on its own. But if the training data we give it reflects historical human biases, by underrepresenting certain environments or languages, then the AI is going to learn and even amplify those same biases. It's a classic case of garbage in, garbage out, but with incredibly high stakes.
And, pretty inevitably, this incredible advantage is now right at the center of global competition. Nations all over the world are racing to develop and deploy these capabilities, and it's creating a new, high-stakes arms race where the battlefield is data and the weapons are algorithms.
So, where does all this lead? Well, we're on a trajectory that really can't be reversed. The challenge for us now is to figure out how to shape this AI-powered future responsibly.
And that next frontier is already starting to take shape. We're seeing these incredible developments like swarm intelligence, where you have groups of AIs that coordinate on really complex tasks, and this big push for true human-AI teaming, turning the machine into a genuine cognitive partner. But maybe the most critical development on the horizon is something called explainable AI.
Explainable AI, or XAI. You see, right now, a lot of the most advanced AIs are what people call black boxes. We know what data goes in, and we know what answer comes out, but we don't really know why it made a certain decision. XAI aims to open that box up, to make the AI's reasoning transparent to us, so that we can trust it, verify it, and ultimately control it. And that is absolutely essential for accountability.
Which leaves us with this final thought. We are building systems that can perceive the world in ways we can barely even imagine. So the most important task ahead isn't just about making them smarter or faster, it's about ensuring that as they learn to see the world for us, they're doing it in a way that aligns with our own goals. The future of our security might just depend on it.